Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Takamoto. And we continue to explain integration of pure mathematics 1, and we are going to look at example 5 on page 174. And before we get to example 5, it is quite critical for all of us to note that before you integrate, you need to ensure that each term of the expression is in the form kxn, where k and n are real numbers. In other words, you're being told that before integrating anything, ensure that each term is in the form kxn. Of course, when k and n are real numbers. The reason why we must ensure this happens is to easily bringing the law of integration in the process, and I'm going to show you how. There are sometimes some numbers are not free, some terms are not free, so you need to free the terms up, free them up. This is the word. Make each and every term as free as possible. Let it not be connected to other denominators where x is at the denominator, where brackets are not opened. First of all, clean it up by either dividing by x when it is at the denominator or by opening the brackets first. Let's see in example 5, part A, because we are supposed to integrate 2 over x cubed minus 3 root x with respect to x. It goes without saying that these terms are not as free as we would wish them to be. This one is not in this form. This second term is not in this form. So we must write them in that form. And we're going to have the integral of 2x raised to power minus 3, as far as the law of indices is concerned, minus 3x raised to power half. Now they are in this form, and they are now as free as they can. So integrating this gives us 2x minus 3 plus 1 minus 2 over minus 2 minus 3x 3 over 2 over 3 over 2 plus c, which basically gives us minus x minus 2. Of course, this one becomes minus 2x 3 over 2 plus c. And as far as we are concerned, that is the final submission. And if you may want to write it in the general form that it was given, then you can just apply your understandings here. For example, you may want to talk about this x minus 2 and take it at the denominator and have minus 1 over x squared minus 2, and then minus 2 the root of x raised to power 3, and of course the root of x cubed plus c. These are just the laws of indices which you can play around with. Part B of the same, integrate x open bracket x squared plus 2 over x, everything with respect to x. And it goes without saying that this one is again congested together. For example, this x affects each and every term in the in the bracket, and this one we need to open the bracket first. So we are supposed to integrate x cubed plus 2, because that is what we get when we open the brackets. Of course, now with respect to x. And this directly gives us x power 4 over 4 plus 2x, and of course plus a constant c. And that is just like it. What I want us to look at keenly is part C of the example 5, which is talking of integrate 2x by itself squared plus the root of x plus 5 all over x squared with respect to x. And what we need to understand here is one fact. And this fact is that we need to free up each and every term here. So how do we go about it? First of all, we have to open this bracket. So the integral of 4x squared plus, you can see these two numerators share a denominator. So we can separate the terms and have like the root of x over x squared plus 5 over x squared. All this with respect to x. Yes, that part was not visible, so let me explain it. We're supposed to integrate 2x squared this term, and you can see this bracket by itself has to be opened first to give us the integral of 4x squared plus these two numerators share a denominator, so we separated the two terms this way, and each one of them was under its own denominator. So it's our duty now to clean up a little bit here, and you're going to have the integral of 4x squared plus, this one is at the denominator, it must go up, and we have x raised to the power half minus 2, because this one is supposed to be subtracted when it gets back there. A half minus 2 is minus 1.5, so we are going to have x raised to the power minus 3 over 2 plus 5x raised to the power minus 2. Now all this now with respect to x, and at that point we are talking of, now we can now integrate because they are now very free. So we have 4x cubed over 3 plus x raised to power, this is minus 1.5 plus 1 minus a half all over minus a half plus 5x minus 2 plus 1 is minus 1 over minus 1, of course, plus a constant. Cleaning it up now, because we have finally integrated, is going to give us what we may call 4x cubed over 3. Of course, dividing by a fraction means multiplying by its reciprocal, and it is negative, so minus 2x minus a half, of course, minus 5x minus 1 plus a constant. If we intend now to write it in the original format how it was, then we can easily say that we have 4 over 3x cubed minus 2 over the root of x, because when x now gets to the denominator, because of this negative power, is going to be x raised to the power a half, that is easily the root of x, minus 5 over x raised to power 1 positive, and we leave it that way, of course, plus a constant. Of course, plus a constant. So finally we have 4 thirds x cubed minus 2 over x, the root of x, minus 5 over x plus a constant. And this is now what we were expected to give in all those levels. Please remember, this example reminds us that we should be able to free our terms before we integrate them. And that is the end of this topic. So it's as short as that, and by extension is the end. No, it's not the end of the topic. We still have example 6. And we are going to explain example 6 in the next video, so please be on the lookout.